These are the unit review practice problems for the momentum unit test. You will need your blue formula sheet and a calculator. Okay, so make sure you're digging those out. In the past, you would turn in your unit tracker sheet right before the test, and you will still do that. You will also turn in this sheet. So this is also going to be your ticket to take the test. All right, so you need to complete this. I'm going to walk you through it. Write down the steps that I write down, and everything should be just fine. So LT1, I can calculate momentum. Remember, that is based on this formula. The momentum is equal to mass times velocity. So for number 1, we have a dog with a momentum of 250. So we have a 250 over here. What would the momentum of the dog be if its mass remained the same, but its speed was halved? Well, we don't have the mass or the speed, but it says the mass stays the same, so we're not going to mess with that. But it's saying, what if it slows down? What if this goes down by 2? We know this is a direct relationship. The mass velocity have a directly proportional relationship to the momentum. So if this is cut by 2, this is also cut by 2. So we know that 250 divided by 2, you may need to plug that into your calculator. 250 divided by 2 should give us 125 kilogram meters per second, because that's the unit for momentum, but we would just type 125 into Moodle. Number 2, a bike has a momentum of 60. So now we have a 60 equals mass times velocity, because no other numbers are given. This time, twice as fast, but mass again stays the same. So this goes up by 2. So you should be thinking, well, I'm not going to divide this side by 2 then. I'm actually going to multiply it by 2. And 60 multiplied by 2 means our momentum is 120 kilogram meters per second. Number 3, what's the momentum of an object that has a mass of 60 and a velocity of 5? Very straightforward. We know that momentum is mass times velocity. So it's 60 multiplied by 5. Pretty easy. 300 kilogram meters per second. And again, we enter 300. So those are the simplest calculations you'll face. And then we get into this impulse-momentum relationship. And hopefully you recall that we wrote a couple new variations down, probably about the last chance to get those onto your blue sheet if you need them. And number 4 says, what's the change in velocity of the ball? It's referring to this basketball. If it hits the ground at 10 and rebounds up at 8. So this is a very elastic type of collision, separate at the end, and heck, it leaves almost at the same rate as it hits. And so if you were the floor, remember, to get the change in velocity, you have to stop this ball and throw it back. So what we add to get change in velocities. So the change in velocity is 10 plus 8, which is 18 meters per second. And we will use that for some of these next problems, or I think the next problem. So now we flip. Number 5. Again, this is an impulse, momentum type of problem, because we see that we're referring to the basketball, and it says we have a force of 32, a time of 1.75, and we're looking for the mass of the ball. Okay, we're looking for mass. So we just substitute in. 32 is the force, 1.75 is the time. That is equal to the mass of the ball, which we're trying to figure out, multiplied by its change in velocity, which from the previous page we saw as 18. We should be able to solve that. Okay, there's some order of operations. We multiply before we divide. So if we type in 32 times 1.75, we get 56. 56 equals 18m. Now we divide by 18. We divide by 18. The answer is, rounding to the 10th, that's our 10th spot. The 100th tells us what to do with it. So the mass is 3.1 kilograms. Moving on, number 6. This is the Blue Yeti, even though I'm writing in red. That's the Blue Yeti. Sled B, what's the impulse needed to bring it to a stop? Most of us at first glance, we look at impulse, see it's force multiplied by time. You're like, what the heck, Lens? There's no force or time. But we also know that impulse equals change in momentum. And we've got to know that to calculate the change in momentum, it's mass times the change in velocity. So if we have a mass of 80, that change in velocity, we would have to bring 24 down to 0. So 80 multiplied by 24 would be 1920. Now the units are strange for impulse because it's a force over a certain amount of time. But regardless, 1920 is what you would type into Moodle. Now, last two here. Remember, you are welcome to use these templates. There should be some extras on the back counter. Okay, you're welcome to, you don't have to. Number 7. This was a problem on the learning target. So we've got a 5 kilogram ball of putty moving to the right. And I'm going to start my table already. This is a larger ball of putty than this one over here. Okay, they have an inelastic collision. So the big ball is moving to the right at 4 meters per second. Head-on inelastic collision with a 2 kilogram ball. So we're just going to go big versus small. So the mass of the big one is going to be 5 kilograms. Mass of the small one, 2 kilograms. 5 kilogram ball is moving to the right at 4 meters per second. So V1I is 4. We are looking for the initial speed of the 2 kilogram ball. So we are looking for V2I. And then, what was getting people on the learning target is for this one, we know the final speed because the combined blob stops. So the final speed is 0. So now what we do is we look at our formula for an inelastic collision where they share the same final speed and we plug them in. So here's the before the collision. There's ball 1. We add it to what is happening with ball 2. Remember, that's our unknown, the initial speed of ball 2. We set it equal to the combined blob, so 5 plus 4, 5 plus 2. 5 plus 2, 5 kilograms plus 2 kilograms. And it is the final speed that we are solving for. No, we're not. See, I did what you guys did. So often we get used to solving for the final speed, but in this case, it doesn't move. So our final speed is 0. That's a 0. All right, so this whole side, 7 multiplied by 0, means that whole side equals 0. So we have 5 times 4, which is 20. 20 plus 2, V2I, equals 0. The first thing, before we multiply even, we should subtract. Subtract 20. Subtract 20. People don't like that we have a negative answer on the right-hand side. It's fine. All right, it's fine. So we have 2 V2I equals negative 20. Divide by 2. Divide by 2. So what was happening is that small blob was moving at negative 10 meters per second. That negative just shows that it was going towards the other one. So since this one had a positive velocity, this one was given a negative one to show what's coming at it. And number 8, we've got a bowling problem. And we know that when you go bowling, it's an elastic collision. All right. So let's just say that mass 1 is the ball, mass 2 is going to be the pin. And so I'm going to let you read through that. Okay, take them in and just start your list. Look at your elastic collision and start your list of the numbers. Anything with a 1, you put it under the ball. Anything with a 2, you put it under the pin. All right, so there's what we got to figure out. We have a 9 kilogram ball. We have a 1 kilogram pin. The ball is moving at 5 meters per second. the pin is at rest. The pin moves off at 2. We are looking for then how fast was that ball going on the rebound, so after it hit the pin. So now, just solving, putting them in here. So we have 9 times 5 plus 1 times 0, set it equal to 9 times what we're looking for, plus, here's what the pin is doing after the collision. So here's all your before the collision, here's all your after the collision. Pause me if I'm going too fast. That drops out. 9 multiplied by 5 is 45. 9v1f plus 2, because we multiplied that out. Order of operations, we do the adding and subtracting first. Subtract 2. So 43 equals 9 v1f. No different than it was 9x. We divide by 9, we divide by 9, and 43 divided by 9 is 4.77 forever. We want the 100th, we want the 10th. The 100th says that we round that 7 up. So the final speed of that bowling ball is 4.8 meters per second. If it were me, I would keep these, study these, and be ready to turn these in when you take the test Monday. The test is live Monday. Talk to you guys later.